Hello guys, welcome back to my channel. Mason African Motives. Still working on engineering, working on mathematics N2. So actually we are going to have a session that we are going to be working on, like on revisions actually for mathematics N2. So we need actually your contribution, guys, on the areas that we can work on, question papers that we can work on, topics that we can work on from question papers, because actually we are preparing for the exams and we shall be working with question papers. So that's it, guys. So for the program, so if you are actually interested in the program, you can actually become part of the family. Like the videos, comment, let me know the areas that we actually need to work on. And also, if you are not part of the family by right now, you can be part of the family by subscribing, so that you'll be having classes for mathematics N2 and also for engineering science N2. So that's it, guys. So let us quickly rush through the question paper that I'm having here. As I'm saying, that these are actually revisions that we are going to focus on. All right, so I hope this part is clear, or let me just try and increase it. Okay, so that was the first question there. We were asked to simplify. All right, so I'm going to write down the question again so that we can actually work this question together. So we are asked to simplify the following. All right, where we are given the fourth root of x to the exponent of 32, that's y to the exponent of 48, everything over x to the exponent of 3, y to the exponent of 4. And if you cross check, that one is just 2 marks for that. Okay, so not waste much of the time, because this is actually revision, guys. What you need to understand from the basic concept of your exponents, we know that this fourth root of the part that we are given of x to the exponent of 32, y to the power 48, like this, it means the same thing as x to the exponent of 32, y to the exponent of 48, like this, everything to the exponent of 1 over 4. That is what this part means from our laws of exponents. Remember, when you are given x to the exponent of 1 over n, that is the nth root of what? Of x. So that's the nth root of x there. So this is the law that you're going to use. So if this is the law that you're going to use, it means now there's a part now with the two terms which are multiplying, and there's an exponent which is outside. So this exponent is going to affect everything. It's going to multiply 32 and 48. Remember, if you're given x m, maybe you're given to the exponent of a and b like this, then you raise to another exponent, maybe c. This is going to affect everything. So it's going to be x to the exponent of ac, m to the exponent of bc. So that's the idea there. So this 1 over 4 is going to multiply. So you're going to have x to the exponent of 32 times 1 over 4. So you're actually multiplying like this, 32 times 1 over 4. This is what you are multiplying. All right, so that 32 times 1 over 4, from our calculator, we've got 32 times 1 over 4. All right, we are going to obtain something like 8 there. So this is what you're going to obtain, 8. And we have got y there. We do the same, 48 times 1 over 4, right? So we multiply again. This term is 48. So you can simply remove this and put 48 there. So it's 40 times 1 over 4, which is 12. All right, so this is what you're going to have. So we have 12 here over this part. I'm just going to write as it is, x to the exponent of 3, y to the exponent of 4. All right, so that is where we are now. Here we are actually dividing. So we are going to apply the laws of exponents, because we've got the bases here which are the same. So remember, when you are dividing, you subtract the exponents. So this one is going to give us 8 to the exponent of 8 minus 3, like this, which is 8 minus 3, which is 5. So you're going to have, I'm writing 8 instead of x. That's x to the exponent of 8 minus 3, which is 5 there, right? We've got y here, so we are going to have 12 and 4, so that's y to the exponent of 12 minus 4, and 12 minus 4, which is 8, so it's y to the exponent of 8, all right? So this is going to be the answer there, or the resultant from the application of laws. So you apply the laws because these are the bases which are the same, and also these are the bases which are the same. So you subtract the given exponents. All right, so that's what we had. Then on number 1.12, that's another question that we had there on 1.12. So let's see how we're supposed to simplify that one. That's 1.12. We'll get 5 to the exponent of minus 3a times 3 times 75 to the exponent of 2a. All right, everything over 3 to the exponent of a by 15 to the exponent of a plus 1. All right, so let's see what we have in this case. If you are to cross-check here, you'll find out that there is a base of 5, a base of 3, then we've got 75 there, 3 and 15. All right, these bases 5 and 3, they cannot be written to the same base. We can't write like 3 in terms of 5. That's impossible. You can't do that. So it means these are going to remain as our neutral bases, this 5 and 3. So what am I going to do? I'm going to have a conversion that I'm going to do from this 75 so that it will be in terms of 3 or in terms of 5. The same thing with 15 so that it can be in terms of 3 and in terms of 5. All right. Just like this 15, I want you to see on this number, which is easier, 15. We know that 15 is 3 times 5. So we haven't changed anything because 3 times 5 gives us 15. So we can write this 15 in terms of 3 and 5. But what about 75? All right. When you are given a number like 75 like this, okay, you want to write it in terms of 3 and 5. What you're going to do is you use this concept, okay? You divide by 3 because that's the smallest number that you have, so that you can see if it is going to give us an exact number there. So let's divide by 3. 75 divide by 3. All right, we obtain 25. So which means when 3 is a factor, we are obtaining 25. All right, so this is now times 25 because we divided by 3. So 3 times 25 is the one that gives us like this. 3 times 25 gives us back that 75. Okay, so from the 25, this one that we have, still we haven't written this in terms of 5. We are supposed to write this 25 in terms of 5. So as we can see now, if we divide by 3, it's impossible because it's giving us a decimal. We are supposed to obtain an exact value. So what am I going to do? Since I want to write this in terms of 3 and 5, I'm going to come back here again. I divide by 5. So I'm going to obtain a 5. So which means 5 here, 25 is the same as 5 times 5. So this can be written as 5 times 5 like this. So 3 times 5 times 5 gives us 5 times 5 gives us 25. Then 25 times 3 gives us 75. But we know that from our laws, in fact, if from normal multiplication, guys, if you multiply a number twice like this, it's the same as raising to the exponent of what? 2. So it's 3 times 5 to the exponent of 2 like this. It's one and the same thing. Just like x times x is x squared. So 5 times 5 is 5 squared. So it means I can rewrite this 75 in terms of 3 and 5 as 3 times 5 to the exponent of 2, or 3 by 5 to the exponent of 2. It's still the same 75 that I had before. Okay, so let's try and enjoy the question here, guys. All right, let's move on and write this stage. 5 is already in its simplest form, so I'm going to just remain as it is. So it's 5 to the exponent of 3 minus 3 over a, like this, okay, times 3 times this 75. So 3 is same as, right, in terms of exponents, 3 is same as 3 to the exponent of 1, okay. This one has no effect. Okay, we are now back to this 75. So we said 75 is same as what? 3 times 5 squared. All right, so this is going to give us 3 times 5 squared, like this, but everything to the exponent of 2a. All right, I divide the denominator here. 3 is already in its simplest form, so I'm just going to remain with 3 to the exponent of a times 15. Remember, we said 15 is the same as 3 times 5. If you multiply 3 and 5, you obtain 15. So this is 3 times 5, but everything to the exponent of a plus 1. All right. So why doing all these parts? What am I going to achieve from this part? This is the question now. All right. Let's start with the brackets first. We know that always when there are brackets, you have to simplify brackets first. So as you can see, there's a bracket here and there's an exponent of 2. So this 2 is going to affect everything here. So this is same as to the exponent of 1. So remember, when there is an exponent and an exponent, you multiply exponent and exponent. So this 2 is going to multiply these exponents from this law. If you are given, let's say, x to the exponent of a times m to the exponent of maybe b to the exponent of c. I explained this. So you're just going to multiply these two. So it's x to the exponent of ac, m to the exponent of bc. You multiply everything by c. So it's the same thing. So which means we are going to obtain this part. It remains as it is. There's no law that we can apply. These two are different, so they are just going to remain as they are. Minus 5, oh sorry, not minus 5, but 5 to the exponent of minus 3a by 3 to the exponent of 1 by, we now affect this by the exponent. So 2 times 1, which is 2a times 1, that's 2a. So it's 3 to the exponent of 2a. All right. Move on to multiplies everything just like b. So it's 2a times 2 now. So 2 times 2, that's 4. So it's times 5 to the exponent of 4a. Remember, this one is under the base of 5. All right. You do the same thing here. Just write as it is again. So it's over. So take note, guys, this is not included. So it's over what? 3 is in the simplest form, so it's going to remain as it is. 3 to the exponent of a times, all right, I'm just going to use a times so that I don't confuse you guys. Okay, so we are back again. 3 times 5 to the exponent of a plus 1. We are doing the same. This is same as to the exponent of 1 to the exponent of 1. So this a plus 1 is going to multiply 1 and also is going to multiply 1 here. So a plus 1 times 1, which is a plus 1. So it's 3 to the exponent of a plus 1 times, we do the same here, 1 times a plus 1, which is 5 to the exponent of a plus 1. All right, so this is what we are having there. So don't freak out, guys. These are just normal numbers. Don't be scared about these expressions. Now just apply your laws. So it's easier for you to start with the denominators, the numerator, then the denominator. You choose the way that you want to do it, but you can just start, or you can just affect those part with x, with the 3 and 5 differently. But as for me, I'm just going to work with the numerators first and the denominator. Okay, so let's start with 5 and 5 here. These bases are the same and they are multiplying. So it's 5 times. So we are now back to that concept where we are multiplying the bases which are the same, where we add the exponents. So it means I'm going to add the exponents. So it's minus 3a plus 4a. So it's 5 to the exponent of minus 3a plus 4a. So this simply means minus 3 plus 4. So minus 3 from your plus 4 from your calculator is 1. So 1a is same as a. So it's 5 to the exponent of a. From this one, you add these two, you're going to obtain 5 to the exponent of a. All right, times, we have got 3 and 3. Okay, these bases are the same. You add the exponents, so you're simply adding 1 plus 2a, which is 3 to the exponent of 1 plus 2a. You can't add 1 and 2a. That's an algebraic and a whole number. These cannot be combined. All right, we move on. Again, in the denominator, we've got 3 and 3. They are multiplying, so you're going to add the exponents. So we've got a and a plus 1. So it's like this: 3 to the exponent of a plus the exponent here, which is a plus 1. So if we add a plus 1 is a plus a, which is same as 1a plus 1a. So it's 1 plus 1, which is 2. So it's 2a plus 1. All right, so this is going to give us 3 to the exponent of 2a plus 1. Okay, we multiply by 5 to the exponent, because this one has nothing to add or subtract. It's just 5 to the exponent of what? Of a, like that. All right, so this is where we are now. What am I going to do now? All right, if you are to cross-check, we are left with division. So this 5 is dividing with this 5, like this. These two here, they are dividing each other, these two. All right, and these two, they're dividing each other, 5 versus 5. So which law are we going to use? When you are dividing, remember, when you are dividing exponents, you versus exponents, there you're going to subtract the exponents. So it's a minus b. So this is the idea here. We are going to be left with 5. We subtract, so it's a minus this exponent. So take note, guys. It's 5. We just work out this separate. 5 to the exponent of a, like this, minus, we are subtracting. Which part are you subtracting? You are subtracting a plus 1. So you have to open a bracket to affect everything like this. All right, so you're going to have 5 to the exponent of a minus times a, that's minus a, minus and a plus, that's minus 1. All right, so a minus a, that's a 0, same as 1. A minus 1 is that, so that's a 0 there. So 0 minus 1, that's minus 1. For 0 minus 1, that's minus 1 there. So you're going to be left with 5 to the exponent of minus 1 times, okay, we have got 3 here and 3. Still these two are dividing, so we have to subtract the exponents. So it's 3 to the exponent of 1 plus 2a on the top there, minus, I open a bracket of what I'm subtracting. What am I subtracting? I'm subtracting 2a plus 1. So it's 2a plus 1, like this, open. Okay, so it's gonna give us 3 to the exponent of what? That's 1 plus 2a minus 2a minus times 1, because this is plus 1, it's gonna give us minus 1. Okay, so let's subtract 1 minus 1. Guys, that's a 0, that one. Okay, 2a minus 2a, that's a 0 again. So we are going to remain with 3 to the exponent of a 0 there. All right, so this is where we are now. This is the stage where we are now. All right, so remember, any number raised to the exponent of 0 is a 1. So this one is the same as we are left with minus 5. So 5 to the exponent of minus 1, like this, times 1, because any number to the power of 0 is 1. So 1 times a number, which means we are going to be left with what? 5 to the exponent of minus 1. So what is going to be the resultant now from 5 to the exponent of minus 1? We know that it's 1 over 5. So 5 to the exponent of minus 1 gives us 1 over 5. Okay, so guys, as you can see, all this whole part that we had gives us 1 over 5. This is the answer that you're going to obtain there. So that's how they ask these questions. Okay, on 1.13 we are given to simplify that log. All right, that's 1.13, we've got a logarithm of 25 in base 2 plus log 4 in base 3. Okay, everything over log 125 in base 2 minus log 1 over 8 in base 3. All right, so there are actually so many ways that we could have worked out this question. Okay, so I'm going to explain this way because remember, I always say that when you're working with logarithms, it's not about the concept that you know, but it's about the question that you're answering, what they actually need you to do there. If you are to cross-check on the top here, we are adding logarithms, but the bases are not the same, so there's nothing that we can do here. The same thing, we are subtracting logarithms. The bases here, they are not the same, they are different. So there's nothing that we can do also there. But there are some numbers which are actually familiar here. 25, 125, 4, 1 over 8. These numbers, they are familiar somehow. Like they can be written in terms of the same number. Like 25 and 125, we can actually write this in terms of what? In terms of 5. How can we write this in terms of 5? We know that 5 to the exponent of 2 gives us 25. So it's a matter of multiplying 5 times 5 until you obtain 25. So you know that that's to the exponent of 2. So 5 to the exponent of 2 gives us 25. So let's write this and see what you're going to have. Okay, log 5 to the exponent of 2 in base 2 plus, what about 4 and 8? These can be written in terms of 2. So in terms of 2, we know that 4 is 2 to the exponent of 2. 4 is 2 to the exponent of 2. So in place of 4, let's write 2 to the exponent of 2. Let's see what is going to happen here. 2 to the exponent of 2 in base 3. Okay, everything over, we have got 125. Still we come back 5 times 5 times 5 until we obtain 125. So you're going to see this is going to give us 5 to the exponent of 3. It is the one that is going to give you 125. Let me just show you here from the calculator. As 5 to the exponent of 3 like this is 125. Are you seeing that? So it means we can write this in terms of 5, which is log 5 to the exponent of 3 in base 2. All right. Minus, okay, this part here I want to explain something. Take note, this is 1 over 8, which is, we are referring to a fraction here. Log 1 over 8 in base 3. Let's talk about the 1 over 8 first before anything else. Before this, let's talk about this part alone. All right. This part here, it means that from our laws of exponents, we know that what made you to write 1 over, it was because you were having a negative exponent. That is what made us to write 1 over. It's because we're having a negative exponent. So if that is the case, it means this 1 over 8 is going to be written like log 8 to the exponent of minus 1 in base of 3. All right, we are still on 1 over 8. Then from the laws of logarithms, we know that if you are given a condition like where you have x to the exponent of maybe m and there's a certain base a, you're going to multiply by the exponent. You drop the exponent, which is m log x base a. You have to drop the exponent. So if that is the case here, we are going to drop this exponent. So it's going to be minus 1, which is just a minus log 8 base 3. Take note, guys. So it's going to be minus log 8 base 3 from this minus that we dropped here. So it will be a minus. It was supposed to be minus 1 log, but minus 1, guys, is same as just writing a minus like that. Okay. So this is what we have in place of log 1 over 8 here. In place of log 1 over 8, we have got minus log 8 base 3. So the question now is, how can we write this log 8 in terms of the numbers that we had, because we are writing in terms of 5 and 2. So 8 in terms of 2, from your calculator, you're going to see that is 2 to the exponent of what? Of 3. That's 2 to the exponent of 3, which is 8. So which means I could have just written this as minus 3. Okay, so 8 from this part is the same as minus log 2 to the exponent of 3 in base 3. Okay, so we are back to this law where we talked about dropping the exponent. So it's still the same thing. There's an exponent of 3. So this 3 is going to multiply minus. So it's 3 times minus 1, which is minus 3 log 2 base 3. So it's now minus 3. All right. So if it is now minus 3 log 2 base 3, we are going to substitute this now in place of minus. There was already a minus which was there. And we are now putting this minus. So this minus is going to change to a plus. So it's now plus 3 log 2 base 3, like this. All right. In fact, okay, I rushed to drop the exponent. I'm seeing it now. Okay, anyways, it's fine. We're supposed to just write it as 2, just like what we had here on these other numbers, because these ones we left that part of the exponent, but still it's one and the same thing. So we're supposed to just like write it as minus log 2 to the exponent of 3, like this. So it was going to be a plus, so it was going to be plus log 2 to the exponent of 3, 2 to the exponent of 3 in base 3, like what we did on others. This is what we're supposed to write here, but it's still one and the same thing, because this is what we're going to do. We are going to drop the exponents still. So, but just an indication to show that you want it to write in terms of the same basis, in terms of the same numbers. That's an indication. All right. So what is going to happen from this case now? We are going back to this law now, because we have got base a log raised to a certain exponent. We drop the exponent and like that. So that is what you're going to apply on each and every of these logarithms. So we've got 2 as an exponent. I'm going to multiply here, drop these 2, multiply to the log. So it will be 2 log. If I drop this exponent 2, I'm going to be left with 5 base 2. So it's log 5 base 2. Okay, I move on. I drop here this 2. So it's going to be 2 plus 2 log 2 base 3. So take note, if I drop this exponent, I'm going to be left with 2 base 3. Okay, I move on to this. I drop the exponent, which is 3. So it's going to be 3 here. So it's over 3 log 5 base 2. Okay, I move on already here. So this is what I was going to do. I was going to drop the exponent, but I already done it here, so I'm not going to do it. So it's just 3 log 2 base 3. All right. So what can we notice from this part? We'll notice that on the numerator there, 2 is common. We've got 2, so you can actually factor out these 2, and I'm going to be left with log 5 base 2 plus, if I factor out 2, I'm going to be left with log 2 base 3. All right, over from this one, 3 is common. Also, I've got this 3 and this 3, so I'm going to factor out this 3. I'm going to be left with log 5 base 2 plus, if I factor out this 3, I'm going to be left out with log 2 base 3. So this is what I'm going to be left with. So what's so important about this? All right, if I'm given something like this in algebra, guys, take note, I'm given 2x over 3x. These two are the same, they can cancel, so that I can be left with 2 over 3. So it is the same thing that is happening. Log this bracket and this bracket, they are the same, guys. Let's look properly. These two brackets are the same, so I can cancel out these brackets. This bracket and this bracket cancel out, so I'm just left with 2 over 3. So that is going to be the result. And as you can see, there's nothing I can do here. This is just 2 over 3. There is no log there. There's nothing. It's just a normal number, a normal fraction, 2 over 3. So that is the idea there, or the concept behind these questions, as you can see. All right, let's see another one. To solve for x if log 16 base x plus log 3 base. Okay, let me just write it on 1.2. So that one has got 4 marks for that. Log 16 base x plus log 27 base 3 minus log 1 over 4 in base 4 is equal to 6. All right, so these guys, they just want to play around with us here. Okay, so what can we do? The first part, I can't like simplify like log 16 base what? Log 16 base x. So this part is just going to remain as it is, log 16 base x. But from my calculations and logarithms, the log 27 base 3, I can actually simplify this. So this is going to give us a 3. Actually, you can use the laws of log. Oh, you just know that 3 to the exponent of 3 gives you 27. So when you are working with the logarithms, you can actually cheat out these questions. Log 27 base 3, you can actually cheat out from your calculator. Why am I saying so? Because that one, whether you used your calculator or not, is the same answer. So there's nothing that is gonna be visible that you used your calculator or not. So we've got log of 27 in base 3, so just put a base there. Then we've got 27, which is gonna give you a 3. So we've got plus 3 here. But what was the exact way of doing this? We just say let log 27 base 3, okay, be equal to x like this. So we've got 27, which is equal to 3 to the exponent of x. Okay, so 3 and 27. So 27 in terms of 3 is 3 to the exponent of 3, which is going to give us 3 to the exponent of x. So we know that when the bases are the same, it means the exponents are the same. So therefore x is equal to 3, which is x is representing the answer to log 27 base 3, which is this 3. All right, so that was the idea there. Okay, I do the same here. I've got 1 over 4. I remember we talked about this 1 over 4 previously. We said it's going to give us to the exponent of negative. But there is a log which is there like this. Log. I didn't talk about the negative. I'm just talking about this 1 over 4 only. So I've got log 1 over 4, which is now log 4 to the exponent of minus 1 in base 4 like this. So what am I going to do? I'm going to drop the exponent, which is minus 1. So it will be minus log 4 base 4 like this. So this minus log 4 base 4, if you were to cross check, there is a minus which was there here. So it will be minus minus, which is a plus. So we've got plus log 4 base 4. So take note, guys, all these stages should be written aside. Then here you just write a simplified answer. But the working, you do it aside, okay? Which is going to give us a 6. Okay, let's move on. Let's just try to simplify further here, because we know that from our laws, the condition of logarithms, log 4 base 4, if you are given log of a number, log a in base a, that one is a 1. Logarithm of a number in the base of that same number, that's a 1. So this is the case, log 4 base 4, that's a 1. So this is plus 1, which is equal to 6. All right, so 3 plus 1, that's going to give us a 4. Then you transpose it to this side. So we are left with log 16 base x, which is equal to 4 minus, that's 4 to this side, 6 minus 4, which is 2. So we are left with 2. So you combine these two first, which is 3 plus 1, that's 4. Then you take that 4 to the other side, it's going to be a minus now. So now let's see how, because the question is to solve for x. So from this part, this is what I'm left with. How can I solve for x? Okay, remember guys, I can convert from both log form and index form. From this part, log a in base b, which is equal to c. It gives us a is equal to b to the exponent of c. So I can convert from log like this back to exponential form. So this is log form, okay, and this is exponential form. So I can convert from this logarithmic form to the exponential form using this concept: log a base b is equal to c. So it's a, this number, okay. So in this case it's log 16 base x. So this is our a here, this is your a, which is 16. So it's 16 is equal to b to the exponent of c. The b is the base, so the base in this case is x. So it's x to the exponent of what? Of 2, like this. Okay, so how can I find x? I have two options. I can introduce square root because there's a squared. So square root x is going to be square root of 16, which is plus or minus 4. But I'm talking of x, guys, which is a base here. So this x can never be a negative. So therefore x is equal to what? 4. So that is the idea there. So from 16 we can also use this concept. 16 is equal to x to the exponent of 2. You just find the inverse of 2, which is 1 over 2. You find inverse of 1 over 2. So x is going to be 16 to the exponent of 1 over 2, of which you're going to obtain 4 from your calculator. So still you can obtain the same value of x using that concept. So that is the idea there. So in order for you guys to simplify these questions or to work out these questions, it's a matter of understanding the basic part of logarithms, the topic that you are working with. So like I'm saying, these questions, they come in different manner and in different formats. So what we need is to have a clear understanding of the basic introduction or part of what? Of logarithms. And also, in order to convert like from a single logarithm to a single exponent like this to an exponential equation is very, very important on your revisions, because this part you're going to apply it a lot of times. You're going to have these typical questions. All right, let's quickly rush on. 1.3, solve for x. Okay, so we're asked to solve for x. Okay, so this one is a pretty direct. Anyways, it's a direct, that one. 4 to the exponent of 2x is equal to 8 to the exponent of 3x minus 4. You're solving for x, and this is 1.3. All right, so how can I solve for x in this case? Take note, it's a condition of the bases here. You have to make sure that the bases are the same on a condition like this. So 4 and 8, we can write this in terms of 2. So 4 is 2 to the exponent of what? 2 from our calculator. 4, that is 2 to the exponent of what? 2 to the exponent of 2. 2 to the exponent of 2, that is 4. But there is already an exponent which is there of 2x. So it's going to multiply like this. All right. 8 is 2 to the exponent of 3. But there's an exponent which was already there, which is 3x minus 4, like this. All right. So why are we writing in terms of the base of 2? Because we know that once these bases are the same, it means also the exponents are the same. So therefore 2 into 2x is equal to 3 into 3x minus 4, because the bases are the same. These two are now equal. So by doing this, you're now left with a normal equation. They are no longer exponents. So just expand your brackets. 4, 2 times 2, that's 4x, which is 3 times 3, that is 9x. 3 times minus 4, which is minus 12. So take note, 3 and 3, that's 9. 3 and minus 4, which is minus 12. Okay, then let's try now collect like terms here. So you're gonna just transpose this, which is 4 minus 9 from your calculator. This is minus 5x. So you subtract here, transpose to this side, you subtract. So it's 4 minus 9, which is minus 5x, is equal to minus 12. So to find x, you just divide by minus 5, both sides by minus 5. All right, so you just divide from your calculator. This is going to give you 12 over 5. That is the value of x, a positive 12 over 5. So like I said, you can actually use your calculator, guys, to divide and so forth. But that is the idea there. That is what we're supposed to actually work out this question. Okay. 1.4, make D the subject of the formula. Okay, in the following equation. Okay, I want to make D the subject of the formula there. All right, so let's see what we have. How can we make D to be the subject there? How can we make D? We are given that S is equivalent to N over 2 into 2A plus N minus 1 into D like this. So this is what we got here. All right, so we want to make D to be the subject. So what I can do, there are so many ways I can expand this part here. So you can see this N over 2. So this one is same as S over 1. So I can like cross multiply in this case. So it's 2 times S, which is 2S is equivalent to 1 times N, which is N, but there's a bracket there, which is 2A plus N minus 1 into D like this. All right. So I have two options here. I can actually multiply by N inside the bracket. So it's going to be 2S is equal to N times 2A. So take note, it's N times 2A, which is 2AN. Okay, plus N times this bracket with a D there. So it's going to be bracket, and we've got N, D and N. They can multiply each other outside the bracket like that. All right. So take note, we want to make D to be the subject here, and this part here does not have D, does not contain D. There is nothing that has to do with D there. So what are we going to do? We are going to transpose this to the left hand side because it does not have D. So it's going to be 2S minus 2AN like that, which is equivalent to, the moment we transpose this is a negative, but we are going to remain with N minus 1 in times Dn like that. All right, guys, take note here. Don't confuse yourselves, guys. When you are given an equation like 2x is equal to 8, how do you solve for x? You divide by 2 because you want to remain with x, so you divide by the one that you don't want on that part. As long as you are multiplying, you can divide by anything. So in this case, that's the idea. We want to remain with D, so we can divide by what we do not need on the right hand side, and what we do not need this N minus 1. So I'm going to divide by the bracket of N minus 1. I do not need this N, so I'm going to divide also by N, which is the same thing here. You divide by N minus 1 times N, because that's the part that is only affecting D, and these two, they are multiplying to D. That's why you can divide. You remove whatever that you want to remove by the opposite of what it is doing. It is multiplying, so you divide. All right, so you can cancel N minus 1, N minus 1, N and N, they can cancel. So as you can see, you are left with the D only here. So therefore D is equivalent to this part, which is on the left hand side as it is. So we are left with 2S minus 2AN everything over N minus 1 into N. So this can be, someone can factor out 2 and write this as 2 into S minus, it's going to be S minus AN. Yeah, S minus AN like this. Yes, there's so many ways, guys. You can write this question in so many ways. So if you have another method that you can apply, or that you think it's gonna work on this part, let's talk on the comment section. Let me know, guys, so that we can work on more revisions and so forth. So that's it, guys. As you can see, that's how they ask these questions on from past exam papers. So we shall meet again working with different typical questions and so forth. So let me know the areas. Yeah, let me know the areas that we can work on, which topics can we work on, which question papers can we work on, so that we can revise more question papers before we write. So that's it, guys, from Mason African Motives. Till we meet again.